And the rent gradient model I like a lot as a teaching tool because it really illustrates a couple important features. One is it illustrates the power you can get out of a model when you kind of make preferences very simple and you push what is a consumer choice problem essentially to become what we'll call a production problem, that it really is a cost minimizing exercise. And the nice thing about thinking about it as a cost minimizing exercise is it really gets away from the whole idea of preferences, right? The question of where to live had nothing to do with my preferences. It was all about where was the cheapest place to live, and that came down to comparing the wage cost of traveling further with the rent savings from traveling further. You could do the same thing for thinking about what kind of car to buy. You could say, well, geez, I need more space, but at the same time, I can trade that off against gas mileage, and so I minimize some cost per unit, something like that. So the more you can restrict preferences, the more you can simplify the model, the better. The more you can push it into a production problem where you can observe the trade-off. The trade-off is not something that can only be inferred from choices. You actually know the components. The better, more powerful your model is going to be, and we saw it in that case. So that's one aspect. The second important aspect is it very clearly illustrates how these kind of what we call hedonic models work. In other words, what we had was we had a situation where we were going to end up, this was travel time, remember, and this was rent. And because everybody preferred a lower rent, right? Everybody prefers, what's the preference direction on this graph? They prefer a lower rent, and they prefer less travel time, right? So the preferences are going to go in that direction. So we know the equilibrium trade-off is going to have to be downward sloping, right? You've got to get a lower rent in exchange for traveling farther. That's no problem. So every consumer is going to choose a point where they're indifferent for between moving a little bit closer. And that was what we said before. We could say, well, geez, that meant our rent gradient had to be convex like that because the highest wage consumers would live closest to the city and the lowest wage consumers would live farthest from the city, right? So the slope at any point would have to be equal to the wage rate of the person who lived there. Otherwise, they wouldn't be maximizing, or in this case, really minimizing cost. Now, that didn't answer the question about where this equilibrium is pinned down, right? Because how do I know it's not going to be, it's going to be this curve? How do I know it wasn't a parallel curve a little bit higher? And that came down to finding our boundary condition. That is the condition that determined where these indifference relationships would start. And in this problem, the natural place to think about the boundary condition was to think about a world in which there was some backstop rent R bar that the land could earn independent of how far it was from the city. And the fact that R bar is flat as opposed to a function of t doesn't really matter. It's just, that makes it simple. So this point is going to be here. And then we used our indifference relationships to figure our way up the curve. So you can think about the central city rent as being kind of determined by kind of an indifference relationship starting from out